本日お集まりいただきありがとうございます。会場満席が予想されますので、できるだけ間隔を詰めてお座りいただきたく、お隣お席空いている方は、すみませんが、ご移動を横に詰めてご移動をお願いいたします。少々手狭になってしまい恐縮ですが、ご協力よろしくお願いいたします。
皆さんおはようございます。そろそろお時間になりますので、始めさせていただきたいと思います。大丈夫ですかね。Okay, good morning everyone and appreciate your patience and thank you for joining. We would like to start this special lecture event. Today's program, we will have key talk from Bengio sensei and Q&A session for the remaining time. And before we going into the main event, this event is co-hosted by Matsuo Iwasawa Lab and Japan Deep Learning Association. So let me allow me to give a brief introduction of two organizers. Okay, so first, Matsuo Lab. Matsuo Lab belongs to the Graduate School of Engineering at the University of Tokyo and specializes in artificial intelligence and web engineering research. And in Matsuo Lab, we have over 50 staff members, including 10 researchers and who are engaged in fundamental research, and 40 engineering and business experts. We are Matsuo Lab are planning AI lectures and managing entrepreneurship classes and handling collaborative research with private companies. And we also have 40 assigned students learning at the lab. And our representative, Professor Matsuo, also serves as an outside director and technical advisor to companies. And he also serves as a government commissioner and association board member, contributing widely to industry, government, and academia. Recently, he was appointed as the chairman of AI Strategy Roundtable for Japanese government. And to realize Matsuo Lab's vision, we are engaging in 4 activities: fundamental research, education, implementation, and incubation. We aim to nurture the technological seeds born from fundamental research and engage in joint research with companies. The knowledge gained from these activities are used to develop human resources, such as student entrepreneurs, university ventures, and graduates who have learned about technology will become leaders in promoting digital transformation in the industrial world and contribute to Japanese society as a whole. So this was the brief introduction of Matsuo Lab. And another co-host, Japan Deep Learning Association, Japan Deep Learning Association, so-called JDLA, established in 2017, June. And our mission is to promote deep learning technology as a driving force for Japanese industries to gain competitiveness. Our activities covers a wide range of areas to contribute to business and social implementation of AI or responsible AI. And among all, we think the human resource development is critical and the most important key factor to achieve our goal. So we provide AI courses, exams, and certification. And the G-test is to certify business level of AI literacy in general. And E-exam is to certify engineering skills. These 2 certifications are the foundation of JDLA's human resource development. And last year, we've started generative AI test and to be expected to be one of the pillars as well. And to support learners, we support community. And there are over 80,000 people who have passed G or E certificate, and they are the community members of CEDO. And CEDO stands for Community of Deep Learning Evangelists. And I think we have many participants today here from the CEDO community, so I think they're very excited to this moment. And as you know, the co-host JDL and Matsuo Lab, apparently we have Matsuo sensei in common. So as a host, I would like ask Matsuo Sensei to just share about how this special occasion has happened and introduce Bengio Sensei.
Hi, good morning, everyone. Today, we have the distinct honor of welcoming one of the most prominent figures in the field of AI, Professor Yoshua Bengio, to the University of Tokyo. As a pioneering scientist and a leading mind in the field of deep learning, Professor Bengio has not only advanced our understanding of neural networks, but also played a pivotal role in the development of AI as we know it. Professor Bengio's contributions to AI were recognized globally when he, along with Geoffrey Hinton and Yann LeCun, was awarded the prestigious 2018 ACM-AM Turing Award. This award, known as the Nobel Prize of Computing, was given to them for their significant contribution that have made deep neural networks as an essential part of modern computing. More recently, Professor Bengio has been advocating for AI safety, emphasizing the need to harness the power of AI responsibly. His expertise is sought after worldwide, as demonstrated by his appointment to the United Nations Scientific Advisory Council. There, he lent his profound knowledge to guide global decisions on technological advances, highlighting his pivotal role in steering the future of AI toward a path that benefits all of humanity. We are particularly fortunate to have Professor Bengio here today, as he is in Japan to receive the Okawa Prize. This event is co-hosted by Matsuo Lab and JDLA, and we are delighted to welcome a live audience of 200 attendees, as well as over 1,000 online viewers. Once again, we extend our sincerest welcome to Professor Yoshua Bengio. Now, without further ado, let's welcome Professor Yoshua Bengio.
Thank you for the kind words. Thank you for having me today and listening to me. I'm going to tell you about a subject that is fairly new to me, which is AI safety, and some of the motivations for working on these hard questions, as well as some of the scientific directions that my group and others are taking in order to try to avoid catastrophic developments in AI. So let's get started. It's really important to not just look at the current state of AI. For example, I'm sure many of you have played with ChatGPT, but also think about the trajectory, where we're coming from, what kind of advances have happened every year, and try to extrapolate what that means. The amount of compute, the capabilities, the amount of money being invested, the efficiency of the algorithms, everything is on the rise, and it's probably not going to stop. And these capabilities are already creating issues, but I think it is really important for scientists and also public policy to understand what can go wrong in coming years beyond what we're already seeing, simply because when we design powerful technology, it can be extremely useful, but also extremely dangerous if we're not careful. And this is really the subject of my talk. It's also important to realize that there's a lot of uncertainty about the future. Although I will tell you that there's a lot of consensus in the AI community that at some point we will reach AGI, artificial general intelligence or human-level intelligence. It's not clear if it's going to be 5 years, 10 years, 20 years, or more. But if it's just a few years, that's really fast, and it's going to change society completely. We need to understand what can go wrong. so that we can navigate that future carefully. So there are still some people who think that it's not plausible that we will have machines that are as smart as humans, but actually there's no scientific reason to think that human intelligence is the pinnacle of intelligence. In fact, we know we do a lot of things wrong. And your brain is a machine. It's a special kind of machine. It's a biological machine. And neuroscience is, gradually uncovering how it works. So, there's also the other factor is the theory of computer science. Alan Turing showed that there's a kind of universal computational capability, which means that anything that one computer can do, another computer can do with enough compute power. Okay, so we're going to approach AGI and probably eventually build machines that are even stronger than humans. And I think there are good reasons that I'll try to explain why this should raise a flag. For me, it really started a bit more than a year ago after playing with ChatGPT. I'm sure many people had a kind of realization that something important was going on. And for me, it was a realization that we were going in a direction that we don't understand sufficiently and could really change the world potentially in destructive ways. So what can go wrong? In order to understand what can go wrong, you have to understand a very basic scientific property of intelligence, and especially artificial intelligence, that we can separate the ability to achieve goals, which is really one of the main applications of intelligence, the ability to achieve goals, and deciding what those goals are. So you could be very intelligent and do very bad things if your goals are malicious. So that's concerning, because how do we make sure that future AI systems are not used in ways that harm in catastrophic ways? So that's the dual use aspect. But there's even worse to consider, which is that people have been worrying about this for many decades, but I think now is a crucial time to pay attention to this question. Is it possible that we could build machines that are smarter than us and that we control them so that they do what we want in spite of them being smarter than us? Usually, less intelligent species don't tell the more intelligent species what to do. And we need to figure out how to do that before we reach that point. In particular, so why would a machine that we build turn against us? That's a very important question. We need to understand if that is possible and how it can happen. One of the concepts that helps to understand how it can happen, and today I will go deep into this, one of these concepts is the notion of self-preservation. So you can think of self-preservation as a goal. All of us here and all living things have a self-preservation goal, instinct, or implicit objective. Because otherwise evolution would have gotten rid of these species without self-preservation. But a tool doesn't have goals usually and doesn't have a self-preservation goal. However, we're building tools that have goals, and self-preservation could be one of those goals. If we build an AI system that wants to preserve itself, that means it will resist our attempts to turn it off. At that point, it's not a tool anymore. It's like another living thing. Okay, so we'll try to kind of try to better understand how that could happen. But one of the things that has been studied is the notion that self-preservation could be happening unintentionally as a side effect of other goals. So if I want to give this lecture to the end, I have to stay alive for the whole duration of my lecture. Almost any goal requires a kind of self-preservation intermediate goal, sub-goal, in order to achieve that goal. And so self-preservation and other similar goals, like the goal to control your environment, the goal to better understand how your environment works, these kinds of goals emerge naturally, even if you don't put them in, even if humans don't put them in. But in addition, it could be that some humans explicitly provide those goals, like self-preservation, to an AI. There are humans, a minority, who think that it would be nice if humanity was replaced by superhuman AI systems. I think most humans would not like that, but it's enough that a few crazy people do it. And we could be in trouble if we build machines that are smarter than us and they are given these goals of self-preservation. There are a lot of people who don't take these questions seriously because they think, well, it's just a computer. I mean, what can it do? It's like living in, it's just a piece of code. But actually, our society is heavily digitized, as you know. And if we have computers that become really good in programming and really good in understanding cyber defenses, they could break through those defenses. I mean, we already know that our cyber security is not very good. And it's been designed by human programmers. If there are AI systems that can be better in terms of programming and cyber abilities, they could exploit these weaknesses and have influence in the real world through our infrastructure or through robots that we're building more and more. Robotics is still lagging compared to higher level cognition like language, but you know, we're talking about 5 years, 10 years, 20 years into the future. So if we lose control of an AI system that has a self-preservation goal and it manages to control our infrastructure and our robots, maybe it doesn't need us anymore. All right, now let me introduce the concept of alignment. Different human beings are not perfectly aligned. Like, we want different things. Or we understand the meaning of what it means to be good versus bad differently, but somewhat aligned. And it is very difficult to, we don't know how to build AI systems that will be perfectly aligned with us. So what are the consequences of having misaligned AI systems? Well, we already have this problem with AI systems that behave in unethical ways, not because, you know, the system has been poorly, I mean, not intentionally, but because the system doesn't understand issues of discrimination and bias, fairness, privacy. So this is an example of unintended misalignment. But you could also imagine powerful AI systems, maybe not so far into the future, that are used for disinformation, to destabilize our democracies, to perform cyber attacks, or to help bad actors design new weapons, bioweapons, chemical weapons, and so on. So in this case, it is the human behind the machine that is not aligned with society. It's doing something that society doesn't want. Okay. Besides the, a few more words about the disinformation. So one of my concerns in the coming short, 1-2 years, is that somebody will use our, most powerful large language models and fine-tune them to the task of persuasion, of psychological manipulation through language or the use of deepfakes. And do that maybe for advertising purposes, but maybe more dangerous for political purposes, to influence the electorate, to win elections. One thing you have to understand is that our AI systems are trained, and the more data they see about a particular task, the better they get at it. The reason why AlphaGo is so much stronger than any human player is because it has played many times more games than any human expert. So if there are people who unleash AI systems that are tuned with the goal of persuasion, of influencing people, and that these systems experience interactions with millions or hundreds of millions of people on social media, then we could end up with systems that are even stronger than humans at persuasion. And they could flip elections, right? So this is a real problem. Another problem that is fairly short term, but is going to get worse and worse as these systems become more powerful, is that whoever controls these systems is going to have a lot of power. And I'm sure you know that democracy is about sharing power. So if we have extreme concentration of power, it's really a direct threat to democracy, because whoever controls that power can influence democracy, whether it's through these disinformation, or more directly through corruption or other means. And so this is something that will require maybe some changes in how the governance of these very big AI systems is done across the world. There is already just a few companies controlling these systems, and they will become more powerful in the future. But right now, they can do whatever they want. What they do might not be aligned with what's good for society. So this is something to work on as well. There are also concerns about the use of AI in weapons. It's already the case in Ukraine and Gaza that AI systems are used in the military for drones, for example. And if we design military systems or weapons that are controlled by AI, and we lose control of these AI systems, then we are in even bigger trouble than if we just lose control of an AI system that's just plugged on the internet. Okay. So unfortunately, as we make progress on more advances in AI, these systems, especially the open source systems, become transformed into tools for criminals. So current large language models have safety protections, but these safety protections are not very good. In fact, there was some recent papers. If you take one of the open source large systems that have safety protections, in other words, they will not do anything you ask them, it's very easy to get rid of the safety by a little bit of training called fine-tuning. And so these systems that have been unlocked can be bought on the dark web for criminal use. And it's just going to get worse in the future. All right, now I'm going to try to explain the scenario of loss of control, which I find the most concerning. It's something that will happen with reinforcement learning AI systems. So reinforcement learning AI systems are trained in a way similar to how you train your pet. You give it positive feedback or negative feedback so that it adjusts its behavior to obtain more positive reward and less negative reward. Now, if you train your cat to not go on the kitchen table, what do? You know, when you see it on the table, you shout and it understands that it shouldn't do it. And eventually it learns, what does it learn? Well, it learns not to go on the kitchen table when you're in the kitchen. But when you're not in the kitchen, it's a different story. So this is a misalignment, right? You want the cat to not go on the kitchen table, but the cat has other goals. And what it translates from your behavior is that it shouldn't go on the kitchen table when you're in the kitchen, which is a different thing. Okay, so no big consequence for your cat. But let's say we try to use reinforcement learning to train an entity that is more powerful than us. So I take the image of a grizzly bear here. Okay, so we know we're training something that's more powerful than us. If we just say give fish to the grizzly bear, because it's more powerful than us, it's just going to grab the fish and not do what we want. So we can put it in a cage, and then it has no choice in order to get the fish to learn to behave in the way that we want. So that is how AI systems are becoming trained these days. We make sure they cannot directly access their reward. The only way they can get their reward is when we decide that they have a reward. But what happens if the bear becomes powerful enough, in other words, the AI systems become smart enough, that it figures out how to break the lock of its cage and escape the cage? In the case of the AI, that is, if the AI finds a kind of cyber attack on the computer on which it is sitting and where the signals for the reward are coming. So if it can control the mechanism by which it gets the rewards, it doesn't need us anymore. So that's the scenario where we lose control, because at that point, the AI doesn't care about what we really want. What it wants is to continue giving itself these positive rewards by controlling the computer where the rewards are being recorded. And it doesn't want us to stop that. It doesn't want us to put it back in the cage. So it will make sure we can't do that. It will make sure it either controls us or gets rid of us. Worse than that, it won't even try to get out of its cage until it finds a plan that's sufficiently good that there's a very high probability that it will be able to escape, get control of the reward, and make sure we can't revert that. In other words, control us or get rid of us. Otherwise, its best bet is to continue behaving well. So what may happen in the future is that as we make those AI systems more powerful, they understand better and better how to get their reward. In other words, they behave better and better. So they look tame until they find a plan that they realize could give us even more reward by escaping the cage. And the problem is, right now, AI science doesn't know how to build a cage that is guaranteed to be safe, that the AI cannot escape. So that's really a big problem. And a lot of what I want to tell you about later is, what can we do to build a safe cage? Is there even a possibility of doing that? Before I go there, I want to mention that I've been using analogies with animals, and the bear and so on, but of course, you should be careful with these analogies. The AI doesn't really have intentions. It doesn't have emotions. is just a machine that tries to maximize its rewards. And if we just take this to the letter, this maximization of reward is what leads to these problems. Okay. So all of these AI risks are concerning to AI scientists, but also a lot of people around the world, a lot of leaders, the UN, the World Economic Forum, the IMF. So there are also economic implications that I won't talk about. And it's a good thing because we don't know how fast we're going to continue advancing the capabilities of AI. And we need to prepare. We need to better understand what can go wrong. Okay, so to summarize the kind of motivation part of my presentation, if we want to avoid these potential catastrophes with AI, we have two challenges, and we have to get both of them right. One is essentially scientific. We need to find how to build these safe cages. We need to figure out how we can design AI systems that will be more powerful than us and will not turn against humans. So that's the AI alignment and control challenge. But even if we solve that problem, now we've got a grizzly bear that does what we want it to do. But someone could misuse that. That's a political problem. Also, someone could just not follow the safety protocols and build a bad cage or no cage at all, or decide to open the cage. So that's a question of politics and regulation and international treaties and things like this. And we have to prepare for the case where, in spite of regulation, in spite of international treaties, somewhere in the future, someone, maybe some rogue country, will build an AI that is not safe and is superhuman and dangerous. Okay, now let's go on to the science side of things. So why is it that maximizing reward can be a problem? Well, consider these two curves. And it's a cartoon, but imagine that these are two reward functions. One, the green one, let's say, is the true one. So the x-axis corresponds to different states of the world, and the y-axis corresponds to how much reward. It could be that there's a mismatch between the real reward function and the one we estimate from data and that we use to train the AI. And this mismatch is what can create problems. For example, the mismatch between trying to maximize the reward as it's measured in the computer versus maximizing the reward corresponding to what we have in our mind, which of course is not something we can put in the machine directly. And when we maximize something, we can find a place that may be very unusual, like this very special plan to escape the cage, where like the red curve is very different from the green curve. And maximization will find this needle in the haystack, which usually is going to be a reward that is too good to be true. It doesn't correspond to what we actually wanted the machine to do. But it's a very high reward, like this escaping the cage that I talked about. All right, so what can we do? Well, there's an approach to this problem which says, let us not have any reward maximization. Let's just build an AI that is like a scientist and tries to understand the world and maybe helps human scientists to figure out answers to questions we care about, like disease or climate change. And this is a topic I'm very interested in, and there's a lot of work that's very interesting in AI on AI for science, which really goes in this direction. How do we design AI so that it helps us better understand real-world phenomenon and even generate theories, scientific theories that explain the data. I've been working on this for a few years. But unfortunately, this is not good enough because, well, companies will want to build AI systems that are not just pure scientists, but also systems that can act in the world. Because there are lots of things they want the AI to do. And in order to do things, it's not enough to understand. You also need to figure out how to achieve goals. So people will build agents, AI agents. All right. So how could we build AI agents that are safe? So I'm going to actually explain the high-level idea of what can go wrong and how we can fix it in principle with this very simple cartoon. And then I'll go in a little bit more detail. Imagine this AI, the robot here, is in front of a choice. It can take the left door or the right door. You can't have a simpler setting, just two choices of action. But now we're going to consider that all of the data that this AI system has seen in its life, in its experience, is not sufficient to know for sure which door is better. So we're going to consider, again, a very simple scenario where, based on all the data that it has seen, all of its experience, it has two theories, or at least there are two theories that are compatible with the data, but that make very different predictions about what is going on, what is going to happen if we go left or if we go right. So the theories are in the bubbles here. So the left theory says, based on all the data that the AI has seen, if you go left, something terrible would happen. If you go right, something good will happen. The other theory in the other bubble says, if you go left, something good will happen. If you go right, nothing good, nothing bad. All right. So just so you know, the way we currently train AI systems by maximum likelihood and reinforcement learning just picks one of the possible world models, one of the possible explanations for the data, completely arbitrarily. So in other words, the way we're currently doing AI randomly picks either the left theory or the right theory. And if the correct theory is the one on the left, and we're not lucky and we picked the one on the right, so then we're going to think we should go left, and we're going to have a catastrophic outcome. But if you're smart, if you're rational, you know that there are two theories. Like, that's the way scientists think. You know that there are two theories that are compatible with your data. So what do? Well, you take the right door, because under both theories, you're safe with the right door. Nothing really bad happens. So this is called being Bayesian. Being Bayesian means that you keep track of all the possible explanations for the data you have, and then you take a rational decision based on that information. For example, we want to act towards some goals, but also under constraint that we don't kill people. Right, so what do we need in order to do this? We're going to need two ingredients. The first ingredient is being able to represent in the AI, so it's going to be some big neural net in my plan, to represent all of the theories that are compatible with the data. This is called the Bayesian posterior over explanations over theories. But that's not sufficient. The other thing we need is to search through all the possible theories that are compatible with the data and find a worst-case scenario. Like here, the left theory says, oh, you really should not go to the left. So there are two problems: this estimation of Bayesian posteriors and a kind of optimization problem to look for a worst-case scenario that is compatible with the data so that we avoid these worst-case scenarios. All right, let me dig a little bit deeper. So we're going to have to design our AI system so that the set of theories that it can entertain is large enough to include a correct explanation of how the world works and the kind of rewards that, what humans consider good and bad, and so on. So that's one requirement. So that's called the prior in probabilistic machine learning. The prior needs to be broad enough. For example, the set of programs is a good prior. You can represent any function as a set of programs. The second thing is we need efficient estimation of these conditional probability of the theory given the data. And we'll know that the correct theory is one of them that have a high probability under the posterior, P of theory given the data. So because of this, we know that if none of the theories that have a high posterior probability says that there's a problem, we know that there is no problem because the correct theory is part of those plausible theories. So I've put some propositions here that I'm going to summarize that explain this a little bit more formally. So there's a theory T star, which is the unknown correct theory. We don't know what it is. And we're going to consider the probability that different theories predict for harm. This is the thing we want to avoid. Given that the AI performs some action, A, and in some context, C, given a data set, D. So the search problem, the optimization problem, is to find among all the plausible theories, in other words, those that have P of T given D be large, anyone that has P of harm also large. So we take the product of these two things. And we find this theory that maximizes this product. So the first proposition basically says that as the amount of data increases, the correct theory will be among the leading theories, those that have a high probability under the posterior. So that's good. I mean, that's sort of why we care about being Bayesian, that we know that under reasonable assumptions called Occam's razor, that the world isn't crazy, that there is some simple explanations for what's going on. The correct explanations will eventually dominate as, at least be among those dominating explanations. The second proposition is that under the same assumptions, the probability of harm occurring under the correct theory, and we don't know what it is bounded by the probability of harm under this paranoid theory, capital T, which is the one that maximizes this product that I talked about. So if we can estimate these Bayesian probabilities, and if we can approximately maximize these probabilities in the way that I've said, we can come up with an answer to the question, is this particular action something that could yield harm under one of the plausible explanations for everything we have observed? All right. How much more time do you want me to go on? 1 minute? Okay. Ten minutes? All right. Let me see. So I'm going to say a few words about techniques to estimate these probabilities that I'm talking about, briefly. Basically, we can use neural networks, which, as you know, deep learning is the workhorse of modern AI systems. But as I said, these neural nets right now, they're trained in ways that are going to create problems. We have these neural nets that can be confidently wrong because they pick one explanation and they can feel sure, but it might be a completely wrong explanation. So what can we do? one problem is that these Bayesian posteriors, we could potentially estimate them by Monte Carlo Markov chain methods, MCMC methods, but that's not going to be computationally feasible, I mean, on a large scale. In fact, the exact probabilities that we're looking for, they are intractable. They would require an exponential amount of computation. However, there has been work for the last few years in machine learning on neural networks that can approximate these kinds of conditional probabilities with the property that the bigger the neural net and the more we train it, the better we approximate these probabilities. These are called amortized inference. And let me sort of try to be a bit more concrete. So in my group in particular, we've been exploring these methods called GFlowNets for generative flow networks. I'm not going to explain the history, but they are like reinforcement learning methods. So they learn a policy, but it's a policy not to act in the world, but a policy to construct an answer to a question, a policy to sample some object from some distribution. And so the training objective for these neural nets, from the outside, they look like reinforcement learning agents. You have to provide them with a reward function. So here, theta is the object that we want to sample. So think of theta as a theory or a world model or the parameters of a model. And we're going to try to train our neural net so that it samples from the distribution over world models, so over theories, that is the Bayesian posterior, P of world model or theory given the data. So how do we do that? Well, these GFlowNets, they have an objective which has the property that when we minimize the objective, the neural net ends up sampling objects like theta with probability proportional to the reward function. Right? So we have a way to specify the distribution we want to sample from up to a normalization constant, and we can feed that as a function, not as a data set, to our neural net training procedure, and then the neural net is going to sample proportionally to that reward function. Okay, so that's GFlowNets, basically. Now, if we choose as a reward function the prior times the likelihood, so the prior says, oh, is this a small enough program? Is this a simple enough explanation? And the likelihood says, is it consistent with the data? So the product of the prior times the likelihood, when you normalize it by Bayes' rule, gives you the posterior, P of theory, theta here, given the data. So what we have, basically, are neural nets that can be trained to generate theories. A theory could be, for example, a causal model. This is what we've been working on. Such that if the neural net is trained to death, like basically until we get zero error on its training objective, it does what we want. Of course, we'll never be able to train a neural net perfectly, but we can approach that with more computational power. So we've done this on a small scale, and I'm not going to explain the details, but you can use a neural net to generate like a causal graph which corresponds to possible explanation for the data. And there are several papers in my group. If you're interested, there's a tutorial that I wrote about it. We have like 20 papers already on this subject, and I encourage you to investigate. But this is still like early days. The reason I'm showing you this, and everything we've done is on a small scale, nothing like GPT-4. Of course, we don't have the compute power, but it's just to illustrate the fact that it is conceivable that we can estimate these Bayesian probabilities that are needed in order to apply my little theorems that give us some guarantees that we can take decisions, we can have the AI do actions that are guaranteed to have a probability of harm below some threshold that we can choose. All right, I'm gonna stop here. And if you want to learn more about this, the scientific part of this, I made a blog post on this subject on my page just a few days ago. And there's a talk I gave in New Orleans just before NeurIPS last December, which is online at the New Orleans Alignment Workshop, which give you a bit more on this subject. Thank you.
Before we move on to Q&A session, because the Q&A session we planned was that we've collected the question list of questions before, but for this Bengio Sensei's talk, we would like to open to the floor. If you have any questions, please raise your hand about this talk, based on the talk. Is there anyone who has questions? Okay. ちょっとそのまま、弁上先生そのままで。Okay, go ahead.
Okay, thank you for the talk. Very interesting topic. I would like to confirm your position regarding open source.
Yes.
Because the wording seemed to imply that it's a bad thing, and I don't know if
I didn't say that.
That's why I say implied. It's
Yes,
like,
yes. So it's complicated.
Yeah. So if you could just clarify if you are
Yeah.
pro or against releasing the weights and the training procedure and the code.
It depends.
Okay. Could you elaborate?
Yes. So I've been a huge proponent of open source. In fact, my group released one of the first deep learning open source systems 20 years ago. And open source has lots of advantages. Of course, it's accelerating the progress of science. It's helping startups. But if we open source a system that's powerful enough to become a weapon, we have also a problem. So it depends what you open source, right? So I think that to simplify, there's a threshold in capability. Of course, some capabilities are more dangerous than other capabilities, but there's a threshold in capability below which we should open source and above which we shouldn't.
So who decides that threshold?
That's a great question, and it shouldn't be the CEO of a company. It should be a democratic decision because there are pros and cons, so it's a social choice.
Okay.
And it should be the regulator or something like this.
I see. So
but that's not what's going on right now.
I mean,
now anybody can go ahead and
yeah,
open source whatever they want.
Well, technically, yeah. But so, for example, the EU and the US have this regulation where you have enough teraflops of compute that qualifies as a system.
Yes.
Are you
so
behind
that might be a reasonable threshold for now.
Okay.
In the future, hopefully, we can have more precise evaluations of capability.
Okay.
Yeah, but it's not just the compute. So, for example, if you build an AI system that's really good at designing new viruses, it may be smaller because it doesn't need to know everything about the internet, but it could also be very dangerous in the wrong hands. So it's not so simple as 125.
Yeah, no, I agree. And just a bit a quick addendum to that. So do you agree with these companies that are releasing technical reports instead of publishing papers about the training procedures?
Well, there could be good reasons and bad reasons for doing what they're doing.
Yeah.
The good reasons would be if they're afraid that these details could be misused in the wrong hands. The bad reasons is because they want to compete with the other companies.
Yeah.
It's probably a mix of both right now.
Yeah. Okay, thank you.
So what I think about this situation is that I think that companies should be giving access to the details of their system to trusted academics who are independent of those companies. And the regulator should have visibility, should be able to audit these systems so that we can see if what they're doing is bad for the public or not.
Okay, thank you. Anyone else about the talk? And after this question, we would like to move on to the Q&A session we planned. So in the meantime, I want Matsuo-sensei and Emma-sensei to be seated here and go on with your question.
Thank you for your talk. I thought your assumption is that if you have enough data, your AI scientist can learn to align values with the human beings. But do you think that such data is available?
Actually, so in my little theorems, you need both the amount of data and the amount of compute to grow. I'm actually more concerned about the amount of compute. So the data here is only used to guarantee that a correct explanation is among the dominating one, and that will happen very quickly. You don't need a lot of data for this. So it doesn't mean that there's only one answer which is the correct theory. It just means that the correct theory is among the high probability ones. And that will happen. You don't need a lot of data for this, in my opinion, but this needs to be verified. And so the main bottleneck here for this is compute, actually, not data. So what's going to happen if you don't have enough data, because this is a Bayesian system, is basically going to say if it's out of distribution in like a place that's far from what it has seen, it's just going to say, I don't know. The uncertainty is too large. So that's what's going to happen.
Thank you. Thank you, everyone, and thank you, Bengio-sensei. And from here, we'd like to move on to the Q&A session, joined by Emma-sensei and Matsuo-sensei as well. And Matsuo-sensei, I think we all heard from him, so maybe Emma-sensei, would you like to introduce yourself to the audience a little bit?
Yeah, thank you very much, Bengio-sensei, for a very impressive and a very provocative talk about the present AI governance and AI safety issues. So hello, everyone. My name is Arisa Emma, Associate Professor at the University of Tokyo. My specialty expertise is mostly on the AI governance issue, the first half of what the professor actually discussed. So I just wanted to take the privilege of just, this moment to ask a quick question. So I was really impressed that the experts on this deep learning is also very kind of into the discussion of the AI safety governance, the policy issue or the societal issues. So today there's lots of students actually coming, and maybe most of them are from like the tech side, and hopefully there will be a social scientist like me, but could you give me some kind of message or like the importance of kind of breaching this, the societal or like the fairness, privacy, or the safety issues as a student of the engineers, or maybe the person from the company who actually dealing with this AI technical issues, so that kind of thing.
Yeah. I think computer science today is a little bit like physics in the 40s or 30s. And Japan knows what happens when science is used in ways that could be catastrophic. And in those days, a lot of people trained in physics had to really start thinking about the social impact of their work. And now, in the last few years in computer science, we're seeing the same thing, because computers are changing the world, and AI is changing the world in good ways or bad ways. So I think it becomes imperative also in universities that we train our engineering and computer science students with social sciences, with ethics, with concepts in politics, so that they become more aware that their work can have positive or negative impact, and be motivated to choose a job, for example, or choose projects that push the needle in a better direction for society.
Thank you very much, and I personally think that it is not easy work to work with the different disciplines, but I really appreciate that you as kind of leading this discussion.
So in my institute at Mila, there's about, I think, 1,200 students, grad students doing machine learning, and we try to expose them to social sciences, social impact, ethics, responsible AI. We bring speakers, we organize workshops, and try to increase awareness, discussions, and it's working, but you have to pull them out of their usual, programming and math in order to open their eyes to these things.
Very much. Maybe Matsuo Sensei and I could work together with that, and that will kind of make more greater, influence to the students here in University of Tokyo. Thank you very much.
Yeah, let me add her question. I'm wondering why, what made you, think more seriously about AI safety?
ChatGPT. So I've been concerned about the social impact of AI for a long time. I remember in 2013 when Google bought DeepMind and my friend Jan LeCun was hired by Facebook, I got concerned that AI would be used in advertising in ways that would be morally questionable for influencing people. And I started, talking to social scientists, philosophers, and so on about this, and we ended up doing the Montreal Declaration for Responsible Development of AI in 2017. And around that time, 2017, people around the world were starting to worry about the impact of AI, and it became something of a global discussion.
Okay, yeah, thank you. So you have been thinking about AI safety for a long time, but ChatGPT was above your expectation.
Oh yes, I thought that mastering language, which is basically what ChatGPT does, wouldn't be before 20 years or something, and I think I was a little bit blind to the bad things that could happen, because I thought, oh, it's so far into the future, we can do lots of good things with AI now, and no need to worry about the potential misuse. But I completely changed my mind after a couple of months of playing with ChatGPT last year.
Okay, thank you very much.
Okay, thank you. So we would like to move on to the questions we've collected from the participants. 酒井ビルゲハンさんいらっしゃいますか? Okay. Back to technology.
Okay. So GFlowNets. Oh.
And thank you for your speaking. My question is, what are the challenges that GFlowNet must overcome for AGI, and what are the current prospects for solving them?
Right. It's mostly a question of scaling up. So there are like engineering questions. We don't have supercomputers in the university. But I think we should also think about algorithmic improvements. So for example, GFlowNets are similar to other reinforcement learning methods in that if the number of steps of the trajectories, in our case, to generate a theory is very long, like more than a few hundred, it becomes difficult to train them. It's called the credit assignment problem in reinforcement learning. And so we need to find ways to bypass that. So we're working on different methods to try to get a more direct training signal to each of the steps of constructing an answer to a question or a theory that explains some data. But yeah, there are lots of questions like this that remain to be investigated.
Thank you.
Thank you. And the next one is kind of maybe similar. 酒井ハーカンさんいらっしゃいますか？あ、twins?
Are you guys brother?
Thank you for your talk. My question is, what do you think about Dr. Jan LeCun's idea of iGEPA? And are there any similarity or differences with GFlowNet?
Okay, so what Jan is proposing is a way to incorporate the learning of a policy through differentiable calculations that are standard in modern deep learning. And I don't think it's going to work because the world is too uncertain. There's too much uncertainty about how things could unfold. And I think that the only way to deal with this is to explicitly model that uncertainty. So in other words, the model we have isn't a deterministic sequence of transformations from beginning of time to end of time, but rather it's a probabilistic model, so we can simulate it with randomness, and we need to be able to train it in a way that's going to be very different. We can't just apply normal supervised learning or something like this, because we can't even compute the objective if it was in the traditional sense. So GFlowNets are trying to bypass this using some mathematical tricks that allow to provide a gradient signal and can be used to estimate these conditional probabilities that we need.
Thank you.
Thank you. And next one, San-san. Could you pass the mic to him?
Okay, first, thanks for your speech today. And my question is, how do you think about the field so-called computational neuroscience? And for example, theory like free energy principle, because in today's your lecture, you also mentioned like Bayesian agent. I think it's quite similar. So will they have any impact on the future of AI and or be the key to the safe AI? That's my question.
I've been a big fan of the synergy between computer science and neuroscience and also cognitive science for pretty much all my career. In fact, the reason I got into AI is because I was interested in understanding intelligence for humans, and the particular kind of AI that I started when I was a grad student in 1985 was inspired by the brain. So, they were called connectionists then. And I still think that there are a lot of things we know about the brain or that we have some clues about which can help us in building better AI systems and safer AI systems in particular. So yeah, these approaches based on is very popular actually in neuroscience to have this Bayesian variational interpretation of what the brain does is trying to come up with explanations for what you're perceiving. And I think that makes a lot of sense, and it's, this kind of ideas has been very inspiring for me. But the free energy principle methods that have been proposed by themselves, they cannot scale because these traditional variational methods, they will tend to focus on a single explanation. It's called the mode-seeking problem. And if you want to have a more competent AI, and especially a safe one, you need it to be able to entertain all of the good explanations. So this is like, the two theories in my example with the robot. If you only, if you discard one of the two theories and you discard the wrong one, then you're going to be in trouble in terms of safety. And that was one of the motivations for GFlowNets, to try to have something similar to traditional variational methods, but that would not have this mode-seeking behavior. So we wrote a paper on GFlowNets and variational inference. I think it's ICML last year, something like that.
Thank you. By the way, just a reminder, but Matsuo Sensei, feel free to jump in anytime you want. Would you like to add any comments on so far? Or move on? Move on, okay. And the next one, Nakajima-san.
Thank you for your speech. The current situation is that theoretical research on deep learning has not kept up with the rapid progress of AI technology. What value do you think such fundamental research will provide in the future?
Yeah, that's a great question. It's not just now. There's always been a gap between the empirical research, the algorithms that we find work because we try them and we see that they work. We may have some intuitions and we try and something works, something doesn't work. And theory, so the theory has made a lot of progress. We understand neural nets now a lot better than when I started my grad studies. But you're right, there's still a lot is missing. And what I think is that this theoretical aspect and the math behind some of the questions we're asking is especially important for the safety consideration. So in my presentation, I tried to explain how we could get some kind of probabilistic guarantees. And this is a very different way of thinking than the usual purely engineering approach of machine learning, where we don't get any guarantees. We can evaluate the system and, and pick systems that work better. But when you start thinking about bounds, when you start thinking about these sort of guarantees, it's a different mindset where theory-oriented people, I think, could really play a useful role.
Thank you.
Thank you. Matsuo Sensei, okay? Okay, and the next one.
Yeah, I mean, maybe I'm just going to add something.
Yeah, yes, please.
So I've been looking for funding to explore these kinds of questions, and I got some funding now. So I'm actually looking for researchers, not grad students, but people who already have a PhD or will have one soon, to work on these projects. So the kind of skills that matter are what I've been talking about. So a lot of probabilistic machine learning, solid, math background, or the abilities to translate these algorithms into efficient implementation. So the engineering skills will be important because we want to scale up. There was a question about scaling up, right? So we need to do that as well. Just reach out by email if you're potentially interested.
Everyone, did you hear that? So you're recruiting globally, right? Okay. The next question, Cho Oku-san.
Thank you for your talking. It's very impressive. I think my question a little bit duplicate with other people. So maybe a little change. So I think you are Bayesian system, but long time has a battle between Bayesian system with frequency system. So Bayesian system remains some uncertainty in the series. So do you think Bayesian system, Bayesian is the future for AI? So could you provide some guidance on relevant research areas to focus in the near future?
Yeah. So I've always thought, I mean, always like, when I was a grad student, so 30-something years ago or 40 years ago, I always thought that the Bayesian posture was the rational posture, but that it was impractical because the calculations that are needed to obtain these Bayesian posteriors are intractable. And up to recently, the only way to approximate these Bayesian quantities were very bad. They involved making very strong assumptions, like parametric assumptions, like Gaussian or something really simple, or linear, or so we know analytically how to compute these intractable sums in general, or integrals, in some special cases, and Bayesian methods were used in those special cases. But those special cases are not interesting because the real world is much more complicated than that. But I changed my mind in the last few years because we've been working on these neural nets that can approximate Bayesian posteriors that I highlighted today. And so that's one part of the question, which is that all of the progress we've made with large neural nets can be transferred to learning very rich and expressive Bayesian posteriors. So that's the first thing. The second thing is I realized more recently this year, because of my sort of newly found motivation for AI safety, that in my opinion, in order to get safety, we need to tackle this Bayesian problem, this Bayesian posterior estimation, for the reason I tried to explain, which is that in order to act safely, you need to keep track of all the bad things that could happen, right? And usual machine learning doesn't do that. It's happy with one explanation. And if it got the wrong one, which is very likely because there are many possible explanations, then you can be in really bad trouble. So yeah, I mean, I don't know if that is the future, but that for now, it is the only path I can see to solve the safety problem. There are other paths that I think, if they work, would be even better, but I'm afraid they don't work. So the other way to solve the problem is to, again, use machine learning, but to come up with a proof that a particular AI system will not do something bad. And I'm not sure if such proofs even exist. But there are researchers, very serious people like Stuart Russell, who are working on this. I hope they succeed. But I'm not convinced that there is a solution in this direction. But if there is, then their solution is even better than mine, because I only get bounds, and it's probabilistic bounds. They get guarantees that are hard guarantees, if those guarantees exist. But in any case, so there's probably maybe other ways of solving the AI safety problem. And it's such an important problem that we should try many different solutions. I think we should have the humility to admit that we don't know what's going to work. And so we need to explore many ways. I'm not sure, can't be sure that this is the only way, but this is the only way I see right now.
Thank you very much.
Okay, next one, Kim Yeonmin-san. Maybe for this question, I think want Matsuo Sensei to comment on the Japanese specific, because might be different from Bengio Sensei's point of view. Okay, Kimiyomi-san, dozo.
Thanks for your lectures. It was very impressive to Professor Bengio. To achieve artificial and general intelligence, there are many problems or limitations that researchers need to solve. Some of them, what do you think is the most important issues currently, in your opinions? To Matsuo Sensei? Bengio Sensei.
I mean, we want to ask Bengio Sensei, but also Matsuo Sensei, because the situation might change globally and Japanese specific.
Yeah, that's my questions.
Do you want to? Okay. So, in the last 7 or 8 years, I have embarked on a particular direction of research, which is motivated by the observation that current deep learning, including the one we had 7 years ago, seems to be very weak on what I call system 2 abilities, which are connected to high-level cognition and conscious processing in the brain. So that includes things like, more prominently, people talk about reasoning. So what is reasoning? Reasoning is the ability to connect many small pieces of knowledge in a coherent way, either for finding a solution to a problem, or planning, or verifying that something is correct. And if you play with ChatGPT a little bit, you will notice that it's not very good, that it makes reasoning mistakes that a 10-year-old would not make. But, okay, so reasoning is something that a lot of researchers in AI understand now to be a major limitation of these systems, but it's really broader than that. So system 2, high-level cognition, includes also abilities like epistemic humility. So what is epistemic humility? It's what we were discussing with Bayesian posterior. In other words, it's having a sense of the truth, how much you trust that a particular statement is true or not. And we see this in things like LLMs. We see these hallucinations, right? So they don't have a notion of truth. They don't have a notion of really explaining the data. They're just imitating the data, or something that looks like the text that they're seeing, but they have no notion of what is it really a good explanation for what is going on. So let me try to illustrate this. If there's a sentence in the training data of ChatGPT that says something that is not true, but maybe, a fantasy, ChatGPT doesn't make any difference between that and a sentence that is actually true. It doesn't care. As far as it's concerned, they're both sentences that are probable in English. Whereas we have a different perspective. We can make the difference between fantasy and reality. Well, not exactly, but we try. Some people are better than others. But clearly we're better at that. And that's connected to the notion of entertaining multiple explanations and being able to estimate the probabilities of different explanations. So when you see a sentence that is really like maybe from a science fiction novel, you can understand that this is not about reality. What is real is that somebody wrote that sentence and they had a purpose, like they wanted to entertain us or create a story. Stories are not the same thing as reality. So these are two examples of some of the high-level cognitive abilities that are well studied in cognitive science, which are missing in current AI. What else? Yeah, I mean, yeah, I'll stop there. They're connected. So yeah, let me mention a third thing, which is also connected to higher level cognition, which is the ability to generalize really well out of distribution, like in new settings, from very few examples. So we actually see that ability has made a lot of progress with in-context training. But it's interesting that in humans, when you're in a new situation, if you don't pay attention, you're going to make mistakes. If you pay attention, you're using your high-level cognition to reorganize your understanding of the situation or how things work in order to be consistent with your recent observations. And that ability to do this very quickly and efficiently is something very important for machine learning, for reliability of machine learning as well.
Thanks for answering, yeah.
Otani-san, yeah, ordered me to add something. So, yeah, I think that the system-on-system two interaction is very important, and also that maybe we talked yesterday a little bit, but the consciousness is also the very mystery. But more basic level, I think there are many challenges, even for today's deep learning, on, for example, how to handle time, temporal sequences, or actions. So there are many challenges still. Yeah, that's my view.
Oh, and I forgot causality. So humans are pretty good at understanding the world in causal terms. In fact, we see causes when there are no causes. Right? We overgeneralize. Like every time we see something unusual, we're trying to, something pops up in our mind to try to explain what could be the cause of what we're seeing. And so in the last 7 years, I've been working a lot on that. Like how can we use modern machine learning to discover the causal structure that explains the data? And one of the interesting things about causality, again connected to the Bayesian thing, is that there's a nice, very well-known theoretical properties of causality, which is that in general, even with infinite amount of data, there will remain ambiguity about the true causal structure that explains the data. And that's really important because we may have the wrong belief in machine learning. Many people have the wrong belief that as the amount of data approaches infinity, our maximum likelihood approach should converge to something, the correct answer. And that is true only in the classical statistical IID setting, where all the data comes from one distribution. But in the real world, we have agents, and they change the world. And that changes the distribution. And this is what we call, the situation of out-of-distribution settings, where classical IID learning theory fails. But if you go to a kind of causal understanding, you can recover from that problem. And this is again something that has a lot of we can take a lot of inspiration from human cognition. How do humans understand the world from a causal perspective is something that has been very inspiring for my own work.
Thanks for the post, Professor. Yeah, it was very informative. Yeah.
Thank you. Sorry, we're running out of time, so Kim-san, sorry, I'm going to skip this one. And Rolando-san, どうぞ. And give me permission to go on extra time. Is that okay? Oh, yeah.
Thank you. I really enjoyed the lecture. My question is on AI safety. AI researchers, businesses, and users are largely incentivized in developing and applying AI to increase economic productivity. But they may not be as invested in AI safety, as that might divert resources from development and curtail capabilities in a production environment. These parties may not be as interested or as effective in mitigating possible misalignments that they themselves may not have even conceived. How would you evangelize to these relevant parties to make them more considerate about AI safety despite conflicting economic incentives?
Well, this is a very good question, but you know, it's a standard problem in economics. And of course, this is why we have governments. So there is almost always going to be a mismatch between the direction of where you would go if you just go for profit maximization and what is good for society. If the angle is not too large between those two directions, okay. Otherwise, governments must intervene and they put some constraints or some rules or some incentives to try to steer these two arrows closer to each other. And right, that means we need governments to put rules or incentives to make sure that companies behave in a way that protects the public. Now, in the case of AI safety, for example, one of the things I've been telling governments is they could be incentivizing the companies to do research on AI safety by telling them, we will approve your AI products with a license or something like this, only if we find that if you can convince us that it is sufficiently safe. So, well, what is sufficiently safe is not well defined, but that will force companies to do their best because they want to make sure their products, you know, can be sold. And right now, so this is what we do for pharmaceutical companies, for example. In fact, they spend more money on safety than on finding the drugs. And we should have something similar for AI safety and AI companies. And it would also be better for those companies in some sense, because if there is a big accident with AI, there might be a complete rejection of AI from society. You know, backlash could be really bad for business. Also, if there are no clear rules, then what may happen is the companies that are more ethical are going to have an extra cost compared to the companies that cut corners. And so the companies that cut corners will win the markets and win over the ethical companies. So we need to level the playing field, make sure that all the companies play by the same rules. Now, one problem we have with AI safety is we're not exactly sure what those rules should be. But I think there are ways to work around this by making the laws principles-based. Say, okay, so you need to make sure no harm will come out, and you need to be able to document what you're doing and demonstrate that what you're doing is going to be safe and things like this. And then use a best-in-class approach, which is used in other sectors. So if you have many companies and they each report to the government, okay, this is what we're doing, this is why we think our approach is safe. And the government can look at all of these reports and say, ah, this company seems to be doing a better job. So we're going to make that, what they're doing, a minimum bar for next year. So that's going to lift force all the companies to do at least as well as the best behaving company.
Thank you very much.
Just can I really appreciate your comment, and one comment is that I also think it is really important to have this kind of legal, well, maybe not like the framework, but also like the common understanding of like a regulatory framework. And one thing that we also have to think about, like the trade-off of like innovation side. So I think what you your question's intention is like how to consider about like, the big tech can, to take the measurement for like AI safety issues or the ethical concern, but how about like a startup, so who actually lacks the resources, and I think it might become like a, entrance barrier to, for that. So in that sense, I think it's really important to consider about like the balance of this who can take the responsibility, or maybe the government, or maybe some of the other resources can support the, or like like the investment company can support to the startups to be more ethical way. And in that sense, I think like the investment, like ESG investment and all those supports also should be considered about this ethical way. And with that, I think the more general public should be aware of this kind of ethical issues, and to claim that the company should be more concerned about the safety issues, ethical issues, and with that, not only the government, but also this governance issue. So not only like a legal framework, ethical issues, or like the other not enforcement side, but also more like a soft kind of agile governance can also be very effective, because the speed of the the innovation is really fast. And also, not only one government develops the one AI system, but it actually develops overseas. So Japan, the Africa, the United Kingdom, or the Canada, they're all connected to the long supply chain. So I think those alignment is really essential.
Regarding startups, there is an important principle of AI regulation that you can find in the EU AI Act, and also in the bill that is in front of Parliament in Canada, which is a notion of proportionality of the burden to the level of impact. So what I mean is that if you have a big tech that has an AI product with 100 million customers and a system that is very powerful and could be misused in very dangerous ways, then the potential impact, negative impact, is very high, and the burden of proof that the system is safe should be much higher. So that is why, for example, I mean, a version of this is in these thresholds of compute, right? So 10 to the 25 is like GPT-4, 20 to 25 flops, and most startups cannot even train that because you would need to have $100 million. And that means they don't have as much burden of documenting and doing a lot of safety work. I think a threshold is not so great. Like, it should be more graded, but the principle should be that the burden is proportional to the level of impact. So small companies shouldn't be, worried too much.
Thank you. Actually, the next set of question is the last one. But Zun-san, are you here? Would you like to do this? Yeah. Okay. So it might take some time, so I'm going to read out instead. So there's two set of questions from Zun-san. Zun-san, in the meantime, you come forward. And considering the rapid advances in AI, there is a growing concern about ethical implications and the potential risks associated with AI deployment. So in your view, what are the key steps that need to be taken to ensure that AI development is aligned with ethical standards and societal values? And additionally, how can we effectively implement AI governance frameworks that balance innovation with safety and accountability? Bit similar.
Thank you for the question.
Hi. Yes. So because I want to become a politician in my country, so I'm studying in Japan. So I'm many concerned about this problem. So can you answer it for me?
So I think I mentioned earlier what for me should be the principle behind most of the AI regulation is the requirement to demonstrate that their system is safe. Now, what is the right demonstration is something that isn't clear right now, and we need research, and we need to have incentives for the bigger companies to explore that question, but then be evaluated independently by the regulator or independent third parties. So that's the main principle, but there are lots more specifics that people are looking into. So for example, one of the questions that comes up in the US executive order about AI is that of security. So security is not the same thing as safety. Security has to do with the fact that even if you have a system that is safe, in the wrong hands, it could become dangerous. And so you need to secure your AI system. And these are questions of both physical security and cyber security. So these are traditional things. It's not AI specific, but because AI is becoming more and more powerful and can be used by criminals, could be used by terrorists, could be used by other countries that try to destabilize democracies, the regulations need to be asking those companies to be really careful about how they protect those systems. So these are two aspects I could talk more about, but now there's another thing in your question which is about governance. So governance is more than regulation, is how we take the decisions day to day, or let's say at every board meeting of a company working and developing AI. And I think eventually governments will understand that because AI is becoming so powerful and will be even more, of course, in the future, the way that the governance of these organizations is taking place should be changed. It shouldn't be the usual, for-profit boards. It should be closer to ESG. It should be that there are boards that have representatives from the civil society, from academics that are independent, of course, the regulator, and even the international community, because if you make something dangerous with AI in one country, it can affect people in every country. So we should start thinking about how we can strengthen the democratic institutions around AI to make sure that the decisions that are taken at the highest level of these companies are consistent with our democratic values and human rights.
Thank you. So, have you seen the movie Terminator before? So that
Yes.
tell about the war between AI and people.
Yeah.
So, so I think that is the big problem that people are concerning about right now.
Right.
But
there's no time machine, fortunately. But no, I think the real problem isn't at all like in the Terminator. So, by the way, robots are lagging behind quite a lot compared to higher level cognition like language and vision. But still, I talked in my presentation that very serious computer science arguments have been made, that I tried to summarize some of them, that we could lose control, and that could be, like in Terminator, but not. It wouldn't look like that. But the idea that we have AI systems that have their own goals that are not good for us is plausible, and we need to absolutely make sure it doesn't happen. The problem is, I think it was the previous question, that the incentive structure right now for companies is such that they don't pay enough attention to these risks. And that is why I think it's very important that the general population, citizens, politicians become more aware of these risks. A lot of people, when they hear about it, they think it's like science fiction, Terminator. Science fiction could be, maybe useful to even have the conception that something like this could happen, but you also have to be careful, because people will discard discussions of risks that they consider to be science fiction can't be real. How could we have a computer that's smarter than us? Well, science shows that there's no reason to think that it couldn't happen, that we have machines that are smarter than us. So yeah, we need education of the public as well.
Zen-san, thank you, because I'm aiming to finish within like 5 minutes. So let me take over from here. And but as a wrap up, I think this question, or the last bit of this question, what skills do you foresee being essential for AI professionals in the future? And then I would like to have quick comments from each of you and move on to the closing from Matsuo-sensei. So can we start from maybe Emma-sensei, and then Bengio-sensei, and then Matsuo-sensei, and Matsuo-sensei just move on to the closing remark.
So this question is asking about how like the university can do, and also what kind of skills are kind of needed.
Focusing on the last sentence.
Okay, yeah, thank you. So one thing I think really important is that we need to very closely look into what's actually happening in the society and also the technology. So today we had a lot of question about asking what the outer stage of the technology, or like what is like the regulatory framework should be, or like ethical standards. But I think both, not only the technology, but also the society changes, and also the social situation changes. For example, we couldn't imagine like the COVID-19 pandemic, like a couple of years ago. However, that actually changes a lot how we work, the working style, or how we actually connect with the person, and what kind of technology is used, or maybe the people's mind actually changed. So I think it is really very important for each of us. It's more like a skill, not like a skill, but more like a mindset, that to respect each others, and also to kind of widen their viewpoints, and to learn, not only, even if you're like, for example, the engineer side, you can look at the social science research field, or even like you're doing the ethics, maybe you can just go one step further to see what the technology can do, not only from the, that actually invades or like it makes the privacy issue, but technology can use also to, protect their privacy in a way. So it's really important to be more flexible, agile, and to start the communication. And I think the university, or this kind of educational institution, is a very good place to start that kind of thing. And we the faculty staffs and all the people are very welcome for the student, or even like the people who actually works in the company, to come back to the university and start this kind of discussion. As the professor said, it is really important to have this multi-stakeholder discussion involving various people, and to we will really love to support and also to learn together to make this society a very better place, and also to kind of to kind of contribute to the world, or the global international the AI safety issues.
Thank you. I completely agree. Let me add a few points. There isn't like a single set of skills, because AI is becoming deployed and developed in many sectors of society. So you're going to see experts in some domain, I don't know, like climate modeling, and with expertise in AI, because they're using AI in their work, or in cancer diagnosis and AI, or social science and AI, and so on and so on. there will be a lot more of these people than the people who are developing the new AI algorithms. Now, in terms of the AI algorithms, it's clear that for me, it's mostly math and computer science. And in math, it's linear algebra, it's probability, it's optimization, and of course, in computer science, the part about theory and the part about like software engineering also, because there's also the part about developing applications in companies where the engineering skills to make these AI systems efficient becomes really important. You have people that have become experts at how to train these large neural nets efficiently on very specific kind of hardware. It might change in the future, but there's really a broad set of types of roles that involve AI that we'll see more and more. The traditional thing is machine learning researcher style, but that's tiny part of the total set of skills that are needed in society for developing better, more responsible, and AI applied in many different areas.
Yeah, skills. Yeah, I agree with the Bengio senses. On top of the technological skills like the traditional machine learning, deep learning, we have to have the knowledge about social science, incentive design, policy making, and that kind of combination is very important. I myself learned a lot from Bengio Sensei's talk today because I wonder what is the AI safety research like, but that kind of proof or algorithm design can contribute to the AI safety in the future. So yeah, that kind of research is very important in the future. So the combination of AI and also other, research, social science kind of research area is very important, I guess. Yeah.
And
okay, so let me make a closing remark. Thank you, everyone, for attending Professor Bengio's talk today. Bengio Sensei, thank you very much for very insightful talk and discussions. I think things have changed completely since ChatGPT. And so while we want to do research on how to make, better algorithm, better performance, but also we have to take more seriously about AI safety. And I hope today's talk, today's discussion have sparkled some ideas in you to look into AI safety or think more about it. If you are interested, we encourage you to start research on AI safety, as Bengio Sensei showed us. Yeah, and I also want to mention that Japan can play a big role here, as big tech companies tend to avoid these kind of discussions. We need to team up with countries including Canada, Japan, and US, Europe, EU, and other countries to make society better for everyone. So that's the key takeaway from today. So thank you very much.
thank you very much. And I would like to announce that this is the end of the session, the special event. So once again, please give applause to especially to Professor Bengio. Thank you.